Let's go continue. Primitive and reference variables. Learning objectives. To understand certain primitive and reference variables, know the type of primitive variables in Java and also that there can be practically an infinite number of different reference variables. You know the difference in behavior between primitive and reference variables when values are assigned to them or when they are used as a method parameters. Variables in Java are classified into primitive and reference variables. For the computer programmer's perspective, a primitive variable information is stored. This is the value of that variable, whereas a reference variable holds a reference to information related to that variable. Reference variables are practically always objects in Java. Let's take a look at both of these types with the help of two examples. In the first example, we create a primitive int variable, and the number 10 is stored as its value. Then we pass the variable to the system output method. The number 10 is printed. In the second example, we created a reference variable called Luke. Luke, a reference to an object, is returned by the constructor of the class of the name class when we call it, and this reference is stored as the value of the variable. When we print the variable, we get name as output. Once called in this, the method calls prints the value of the variable. The value of the primitive variable is concrete, whereas the value of a reference variable is a reference. When we attempt to print the value of a reference variable, the output contains the type of the variable and the identifier created for it by Java. The string name tells us that the given variable is of type name, and its identifier says the previous example applies whenever the programmer has not altered an object's default print format. You can modify the default print by defining the toString method within the class of the given object, where you specify what the object print should look like. In the example below, we define the public string toString method within the name class, which returns the instance variable name. Now we print an object that is an instance of the name class with the system output command. The string returned by the toString method is what gets printed. Primitive variables. Java has 8 primitive variables and 8 different primitive variables. These are boolean, true value, either true or false, byte containing 8 bits between values. 100 minus 100, negative 128, and 127. So are uh, a 16 value representing a single character stored a 16-bit value that represents a small integer between the values. 32,768 and 32,767. Int a 32-bit value that represents a medium-sized integer between the values 231 along 64-bit value that represent a large integer between values. A floating point number that use 32 bits, and double a floating point number that use 64 bits. These we've mainly been using the truth value, boolean, integer, and floating point variable double. Declare a primitive variable causes the computer to reserve some memory where the value assigned to the variable can be stored. The size of the stored container reserve depends on the type of the primitive. In the example below, we created 3 variables. Each one has its own memory location to which the value that is assigned is copied. The name of the variable tells the memory location where its value is stored. When you assign a value to a primitive variable with an equality sign, the value on the right side is copied to the memory location, indicated by the name of the variable. For example, the statement int first reserves a location call first for the variable and then copies the value 10 into it. Similarly, the statement int second first reserves in memory a location call second for the variable being created and then copies into it the value stored in the location of the variable first. The values of variables are also copied whenever they are used in method calls. What this means in practice is that the value of a variable that passes as a parameter during a method call is not muted in the calling method by the method call. In the example below, we declare a number variable in the main method whose value is copied as is the method call parameter. In the method being called, the value that comes through the parameter is printed, and its value is then incremented by 1. The value of the variable is then printed once more, and the program execution will finally return to the main method. The value of the number variable in the main method remains inaltered because it has nothing to do with the number variable defined as the parameter of the method that's called. Reference variables. Out of the variables provided by Java, other than 8 primitive variables mentioned above, are reference type. A programmer is also free to create their own variable type by defining new classes. In practice, any object instance from a class is a reference variable. Let's look at the example from the beginning of the chapter where we created a variable called levy of the type name. The code has following parts. Whenever a new variable is declared, its type must be stated first. We declare a variable of type name below. For the program to execute successfully, there must be a name class available for the program to use. We state the name of the variable as it's declared can reference the value of the variable later on by its name. Below, the variable name is defined as levy. Levy. Values can be assigned to variables. Objects are created from classes by calling the class constructor. These constructors define the values assigned to the instance variable of the object being created. We're assuming in the example below that the class name has a constructor that takes a string as a parameter. The constructor of how returns the value that is a reference to the newly created object. The equivalent sign tells the program that the value of the right hand side expression is to be copied as the value of the verb on the left hand side. The reference to the newly created object returned by the constructor call is copied as the value of the variable levy. Levi. The most significant difference between primitive and reference variables is that primitive usually numbers are immutable. The internal state of a reference variable, on the other hand, can physically be muted. This has to do with the fact that the value of a primitive variable is stored directly in the variable, whereas the value of a reference variable is a reference to the variable data at its internal state. Arithmetic operations such as addition, subtraction, and multiplication can be used with a primitive variable. These operations do not change the original values of the variable. Arithmetic operations create new values that can be stored in the variable as needed. Conversely, the values of reference variables cannot be changed by these arithmetic expressions. The values of a reference variable, that is, the reference, points to a location that contains information relating to the given variable. Let's assume that we have a person class available to us, containing an instance variable age. If we instantiated a person object from the class, we can get our hands on the age variable by following the object reference. The value of this age variable can then be changed as needed. Primitive and reference variable as the math parameters. I mentioned earlier that the value of primitive variable is directly stored in the variable, whereas the value of a reference variable holds that reference to an object. We also mentioned that assigning a value with the equivalent sign accompanies the value possibly of some variable. On the right hand side, and store it as the value of the left hand side variable. A similar kind of copying occurs during a method call, regardless of whether the variable is primitive or reference type. The value passed to the method as an argument is copied for the call method to use. With primitive variables, the value of the variable is conveyed to the method with reference variable. It's a reference. Let's look at this in practice and assume that we have the following person class available to us. We will inspect the execution of the program step by step. The program's execution starts from the first line of the main method. A variable of type person is declared on its first line, and the value returned by the person class constructor is copied its values. The constructor creates an object whose birth year is set to 1970 and whose name is set to the value received as a parameter. The constructor returns a reference. Once the rule has been executed, the program states in the following: the person object has been created in memory, and the first variable defined in the main method contains a reference to it. In the illustration below, the call stack is one on the left-hand side and the memory of the program on the right. On the third row of the main method, we print the value of the variable first. The method calls in out program searches for the toString method on the reference variable that has been given to it as the parameter. The person class has the toString method, so this method is called on the object referenced by the first variable. The value of the main variable is in that object is first, and the value of the birth year variable is 1970. The output becomes first. In the fourth row, the program calls the useVan method, which we pass the variable first as an argument. Argument is an argument. When the method useVan is called, the value of the parameter variable is copied to be used by the useVan method. The execution of the main method remains waiting in the call stack, as the variable first is a reference type. The reference that was created earlier is copied for the method used. At the end of the method execution, the situation is as follows. Method increments the birth year of the object it receives as a parameter by 1. When the execution of the method make younger ends, we return back to the main method. The information related to the execution of the make younger disappears on the call stack. Once we return from the method call, we once again print the value of the variable first. The object referenced by the variable first has been muted during the useVan method call. The birth year variable of the object has been incremented by 1. The final value is printed in first. New person type variable call second is then declared in the program. The value of the variable first is copied to the variable second. That is, the value of the variable second becomes the reference to the already existing person object memory. The program calls the useVan method after this, which is given the second variable as a parameter. The value of the variable passed during the method call is copied as a value for the method. That is, the method receives the reference contained in the second variable for its use. After the method execution, the birth year of the object referenced by the method, in fact, has increased by 1. Finally, the method execution ends, and the program returns to the main method, where the value of the variable first is printed one more time. The final result of the print is first modifying an object variable. This number will be printed. Time machine. What will be printed? The class. Oh, what? Let me see again. Person Lorraine, new person. Right here. Let's see. Machine. Oh, I use the object. Or this is to count the view. Receive the object. Yeah, that makes sense because the variable. I create the name of the class, the name that we call the class person with Lorraine. Lorraine, what was received here? In fact, it wasn't received; it just was attributed to that name the year. So I send the name to the time machine. Rain. Person. Oh, I didn't feel that. So one class is linked to the other. Person, traveler. So it will search for the person that I create here. A person, time travel, this person, rain. Oh, that makes sense. 2 minutes for midnight. Oh, that makes sense. I didn't see that. That's why I answered wrong firstly. Anyway, let's finish. Yeah. Variables in computer memory. In the course materials, concrete details related to variables in computer memories are simplified. Topics related to memory are dealt with on a level of abstraction that's suitable for learning programming. As an example, the description that the statement int number receives the location for the variable number in the memory and copies the value file into it. It is sufficient with regard to the learning objectives of this course. From the perspective of the operation system, a lot more happens when this statement is executed. A locker of size 32 bits is reserved in memory for the value, and another one for the number variable. The size of the location is determined by the type of the variable in question. Most of this is done the context of the memory location, showing the values find are copied into the memory location of the number variable. To add to the above, the number variable is technically not a memory location or container. The value of the memory address is the address in memory. Information attached to the variable amount is style specify how much data should be retrieved from its address. An example, this is 32 bits for an integer. We return to this briefly in the advanced programming course. The topic is dealt with in depth, depth in the computer organization course. Okay. Oh, it's break time. Let's go. Objects and reference. Learning objectives. You will brush up on using class and objects. You know what a new reference is and what calls the new pointer exceptions. You can use an object as an object variable and a method parameter. You can create a method that returns an object. You can create the method equals, which can be used to check if two objects with the same type have the same contents or use case. Let's continue working with object and reference. Soon we can use the class that represents the person shown below. Person has object, variable name, age, weight, and height. Additionally, it contains method to calculate the body mass index among other things. Precisely what happens when a new object is created. Calling a constructor with a command. New causes several things to happen. First, space is reserved in the computer memory for storing object variables. Then default or initial values are set to object variables. For example, an int type variable receives an initial value of 0. Lastly, the source code in the constructor is executed. Constructor call returns a reference to an object. A reference is information about the location of the data of object. Location of object data. So the value of the variable is set to be a reference. That is the knowledge about the location or of related object data. The image above also reveals that strings the name of our example person, for instance, our object is. Assigning a reference type variable copies the reference. Let's add a person type variable called ball into the program and assign John as its initial value. What happened then is a second person ball creates a new person variable ball and copies the value of the variable John and its value as a result. All reference refers to the same object as John. Let's inspect the same example a little more thoroughly. John, I don't think I'm doing it correct. John. John ball. That is the person object that views the person object that the reference in the John variable points at, such as 0 years old. After this, the value of the John variable is assigned to copy to the ball variable. The person object ball is issued by 2 years in John issued as a consequence. An object's internal state is not copied when a variable value is assigned. A new object is not being created in the statement person ball John. The value of the variable ball is assigned to be the copy of John values that is a reference to an object. Next, the example is continuous so that a new object is created for the John variable, and the reference to it is assigned as the value of the variable. The variable ball still refers to the object that we created earlier. The following is printed. So in the beginning, the variable John contains a reference to an object, but in the end, the reference to another object has been copied as its value. Here is a picture of the situation after the last line of code. new value of a reference variable. Then extend the example further by setting the value of the reference variable down to null. That is the reference to nothing. The new reference can be set as the value of any variable of any reference type variable. First one, the situation of the program after the last line is depicted below. Depicted. The object whose name is your ball is referred to by nobody. In other words, the object has become garbage. In the Java program language, the programmer is not fool about the program's memory use. From time to time, the automatic garbage collector of the Java language cleans up the object that has become garbage. If the garbage collection did not have the garbage object would reserve a memory position to the end of the program execution. Let's see what happens when we try to print a variable that returns nothing that is new. A new reference print new. However, how about if we were trying and call a method, say equal order on an object that refers to nothing. The result, bad things follow. This could be the first time you have seen the test no point exception in the course of the program. There occurred an error indicating that we call a method on a variable that refers to nothing. The promise that this is not the last time you will encounter the previous error. When you do, the first step is to look for a variable whose value could be null. Fortunately, the error message is useful. It tells which row caused the error. Try out yourself. Oh, I skipped the remove repeating code overloading method in constructor. What for sake was an object in reference? What a mess, isn't? We'll do the null point exception. Do not forget the learning what I learned here. But after that, I will go back to the other exercises that I simply skipped. I'm having trouble to do that lines and no, now it all happen, I think. Or no. Auto bound exception. In fact, I think I will do nothing here to uh not because my life was going straightforward. No, we're not without any mistake. Like let's do exercise 1, 2, 3, 4, 5 without skipping and no one. So I will forgot, forgot that part here. I forgot that part, and now I will go to removing repetitive codes. But I will speed run that part. Maybe go to that objects and reference. So let's go. Removing repetitive code, overloading method and constructor. Learn objective, becoming familiar with the term overloading. Create multiple constructor for a class. Create multiple methods with the same name in a class. Let's once more return to our person class. It's going to look like this. A person object or years old when created. This is because the constructor set the values of the instance variable aged to 0. Constructor overloading. We would also like to be able to create persons so that the constructor is provided both the age as well as the name and parameters. This is possible since a class may have multiple constructors. Let's make an alternative constructor. The constructor can remain in place. We now have two alternative ways to create an object. Well, we now have two alternative ways to create objects. If the constructor, if you don't assign the age, the other constructor will be called. The technique of having two or more constructors in a class is known as constructor overloading. A class can have multiple constructors that differs in the number and or type of their parameters. Not, however, possible to have two constructors with the exact same parameters. You cannot, for example, add a public person string, name, and age. On the other side, it would be impossible for Java to differentiate. It would be impossible for Java to differentiate, 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 differentiate between this and the one that has two parameters, where each parameter is used for age. Following your constructor. Hold on a moment. We previously concluded that copy-paste code is not a good idea. When you look at the overloaded constructors above, however, they have a lot in common. We're not happy with this. The first constructor, the one that receives a name as a parameter, is in fact a special case of the second constructor, the one that's given both name and age. What if the first constructor could call the second constructor? Yes, it's possible. A constructor can be called from another constructor using the key using the this keyword, which refers to this object in question. Let's modify the first constructor so that it does not do anything by itself, but instead calls the second constructor and asks it to set the age. The constructor called this might seem a bit weird. Weird way to think about this is to imagine that the call is automatically replacing with copy paste of the second constructor in such a way that the age parameter is set 0. Note, if a constructor call another constructor, then the constructor call must be the first command in the constructor. New object can be created just as before. Let's see. Overloading a constructor. Below is a class that represents a path. What will the program below print? Constructor overload. The exercise template has a class product, which represents a product in a shop. Every product has a name, location, and weight, and the following three constitute to the product class. Okay. You can test your program with the following code. Read a product with a given name and a given weight. Okay, let's go. Let's go. Let's go. Rồi.
Joy to the world, the Lord is come. Let earth receive her King. Let every heart prepare him room. And heaven and nature sing. And heaven and nature sing. And heaven and nature sing. Joy to the world, the Savior reigns. Let men their songs employ, while fields and floods, rocks, hills and plains repeat the sounding joy. Repeat the sounding joy. Repeat, repeat the sounding joy. No more let sins and sorrows grow, nor thorns infest the ground. He comes to make his blessings flow, for as the curse is found, for as the curse is found, for as the curse is found. He rules the world with truth and grace, and makes the nations prove the glories of his righteousness, and wonders of his love, and wonders of his love, and wonders of his love.
Okay, let's go. Method overloading. Methods can be overloaded in the same way as constructors. That is, multiple versions of a given method can be created. Once again, the parameters of the different version must be different. Let's make another version of the row order method that ages the person by the amount of years given to it as a parameter. The example below, Paul is born 24 years old, ages by a year and then by 10 years. A person now has two methods, both called row order. The one that gets executed depends on the number of parameters provided. We may also modify the program so that the parameter list method is implemented using the method rule order use. Overloading a method. The load is a Java class that represents a comment. Okay, I'm back. Let's load the music page. A bit slow, huh? That sounds so Canadian. Anyways, let's read this. Overloading a method. What will the following program print? The counter 1 and 3. Here will be 3, 4, 5. Okay, let's do that exercise now. Overload counter. Let's open it. Implement class call counter. The class contains a number whose value can be implemented and decremented. The class must have the following constructors. That the start value of the counter to 0. Alternative method. Implement version which are given one parameter of the method. Increase and decrease. Develop by top divided. Put decrease. Okay. The value by if the value is negative, the value of the color does not change. Okay. Now we can safely continue objecting reference into the null pointer exception. Here, that exercise. So let's do it now. How can I do that? I think I will do the same way here. I will create a method and call the method with a variable that normally will give no. An easy way to happen is the no-point exception. I was thinking too much in fact. I don't need to go to the easy way, or better yet, the simplest way. What is simple works most of the cases. But anyway, object is a method parameter. We have seen both primitive and reference variable x as method parameters since object or reference variables, and the type of object can be defined to be a method parameter. Let's take a look at a practical demonstration. Amusement park rides only permit people who are taller than a certain height. The limit is not the same for all attractions. Let's create a class representing an amusement park ride. To create a new object, the constructor receives a parameter as parameters the name of the ride and the smallest height that permits entry to the ride. Then let's write a method that can be used to check if a person is allowed to enter the ride. So if they are tall enough, the method returns true if the person given as the parameter is permitted access and false otherwise. Below it is assumed that person has the method public int get height that returns the height of the people. So the method allows ride of amusement park ride object is given a person object as a parameter. An earlier value of the variable, in this case the reference copied for the method to use. Method handles a copy reference and it calls the get height method to the person passes the parameter. Below is an example main program where the amusement park ride method is called twice. First, the applied parameter is an object first, the person object map, and the person object Jasper. The output of the program is what if we want to know how many people have taken the ride? Let's add an object variable to the amusement park ride to keep track of the number of people that were permitted to enter. Now the previously used example program keeps track of the number of visitors who have experienced the ride. The output of the program is assistance creation.
Transparenz. 'Transparenz. 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 'Transpa
creating a constructor, getters, and setters. Development environment can help the programmer if you have created object variables for a class. Creating constructor, getters, and setters can be done almost automatically. Go inside the code block of the class, but outside of all the methods, and simultaneously press Ctrl and space if your class had example object variable balance. That means offer the option to generate getter and setters method for the object variable and a constructor that assigns an initial value for that variable. On some Linux machines, like the ones on the Cupola campus in Virgin High, this feature is triggered by simultaneously pressing Ctrl, Alt, and Space. Okay, now it's break.